In this tutorial, I'm going to show you how you can write a bash script to assemble metagenomic sequence data. Okay, so in this tutorial, we are going to deal with multiple samples. We are going to use Megahit to do this. Now, if you have a single sample, like in this case, the files here are all paired and reads. So this and then this will form a single sample. So if you are dealing with a single sample, it's easy to write a script to assemble the data. You can even execute the command on the terminal. Okay, but then if you have lots of samples, if you have multiple samples, like in this situation here, then it becomes challenging, especially if you are dealing with paired and reads. So in this tutorial, I'm going to explain everything to you. I'm going to give you the steps that you can use to write your own bash scripts and assemble a metagenomic sequence data. And this particular tutorial, the knowledge you get from this tutorial can also be applied on other data sets. If, let's say, you are assembling, let's say, sequence data using spades or other assembly tools, you can use the same principle. Okay, so it's all boils down to you having a good naming convention. If you have a good naming convention, it becomes easier to take the files and then process them. So I'm going to give you all these tips in this tutorial. But before we start, you need to make sure that you have installed Megahit. I have tutorials that show how to install Megahit. So just check the description box and you find those links. So after getting Megahit installed, you also need to download the data. So let me show you where you can download the example data. We are going to download everything here and then use them. So let's download the data. The example data we are going to use for this exercise can be found on this page. I will leave the link to this page in the description box. This is a gallery tutorial. It shows how to perform assembly of metagenomic sequence data. So I'm using the example data that was given here. So when you are here, just scroll down, and then you come to the agenda section. Then you can click on prepare analysis history and data. So when you click it, you'll be sent to the section which has the information we want. And that is the download links to the files. So scroll down a bit and you are going to see the links there. So if you want to download, you can just highlight and then click it. Click the link that you have highlighted. And then this will allow you to download the files. But we have lots of files here. And so you clicking it one by one and then downloading can be cumbersome. Okay, especially if you have hundreds or thousands of files that you want to download. So there is a better way to do this. So we can do everything on the command line. Okay, using the command line. So I'm going to show you how to write a bash script and then use that to download all these files. So first of all, let us copy everything. So I'll just highlight and then copy like what I've done here. And then I'll move to the terminal to download it. So on the terminal, I'm going to create a directory called Metagenomics. So I'll say make the Metagenomics. This is going to be my working directory. So I'll cd into it. And then I'm going to create two files. One of the files will contain the download links. And then the other file will contain the command we are going to use to download the files, or the commands we are going to use to download the files. So I'll first create a file. And then this file, I'm going to paste the download links into that file. So it's a text file, a normal text file. Okay, so that means I'll have to open it. So I'll say nano, and then I'll say download links.txt. You can use any text editor of your choice. Okay, I repeat, you can use any text editor of your choice. Nano, VI, Vim, or whatever, you can use that. And then this name here, you can also use any name of your choice, but I want to describe the file. I want the file name to be descriptive. So that's why I'm using download links. So I'll now open this file and then I'm going to paste the download links here. So these are the links. So I'm now going to exit and save changes. Okay, that has been done. So let's do an ls, and we are going to find the file there. So you can even display the content. You can say cat download links.txt. This will display everything for you. You can also count the number of files here. So you can say wc-l, and then we specify the download links. We are going to get 12. Okay, so we have 12 files to download. So in other words, we have 6 samples because these are paired and reads. Okay, because we have read 1 and then read 2. So take note of that. So let's create the bash script now. So the bash script, I will say nano, and then I will say download data.sh. I'll add my shebang line, and I'll move to the next line. So this is where I'm going to write my bash commands. So first of all, I need to get the content of the file. Okay, the file that has the download links. So the file is here. If you do an ls, you are going to find that file, this file here. We are going to read it. So I'll do this. I'll say links, or let me just say download links, download links. And then I'll say equals, and then I'll add this bracket, and I'll say dollar. I'll add another bracket, and I'll say cat download links.txt. So this is what you are doing. The cat will display the contents. Okay, but instead of displaying, we want everything, the result of everything. That is what this dollar here means. So that means that everything, the result that has been given. Okay, not the command itself, but the results, the output. Okay, the output that has been given or that will be returned. Everything should be placed in a bash array. So this is the array. So the array is represented by this 2 brackets here, the external ones here. That is what we have. So in other words, this command will return an array. So an array contains information. Okay, so in our situation, the array will contain the download links. We have 12 of them. So that is what this command is doing. Perfect. So now that we have this, we can now say for link in dollar, and then I'll bring a curly bracket, and I'll say download links. I'll bring a square bracket at, and then I'll close it. So here, what I'm doing is that I want everything that has been assigned to this variable, all the contents of that bash array. I want everything. That is what this square brackets and at will do for us. So the dollar here is also representing the actual values of whatever is here. So this is the loop, a for loop. So after doing this, I'll say do, and then what I'll do is I'll say wget, and I'll say dollar link. And then the next line, I'll say done. wget will be used to download the file. Okay, or the files, because we have multiple files here. So wget will be used to download the files. Okay, so we are going to download them one by one. That is what this command will do for us. There's also another way we can use to download everything at once, but that's something I'll cover in another tutorial. But for now, let's do this. Okay. So if you have any challenge, if you have questions, you can reach out to me. And if you also have some data sets you want to download, and then there are lots of links, you can always reach out to me. We can have a session, and then I'll show you how to download all those files. I think I also have one that you can use for, I have some scripts you can also use to download files from SRA. So if, let's say, yours is about SRA, you can just contact me, and we can just work something out. So that's about it. So let's exit and then save the changes. Perfect, that has been done. So we are now going to execute this script. We are going to use bash. So I will say bash, and then I will say download underscore data.sh. So I'll execute this command now. Perfect. So everything is being downloaded now. So you can see the files being downloaded. So now we are downloading this particular sample. So let's wait for all the files to get downloaded. Okay, the files have been downloaded. So let's take a look at them. Let's do an ls, and we are going to find the files there. What we are going to do next is to move these files to another directory. So we are going to create a directory called fastq. So let's create a directory called fastq. So I'll say make the fastq, and then I'll move all the fastq files there. Okay, so I'll say mv star.gz, and then I'll say fastq. So here we are moving all files that have their names ending with .gz, and these are the fastq files. So I'll move them there. Perfect. So let's do an ls. We are not going to find the files here. We are going to find them in the fastq. So let's do an ls into fastq directory. So these are the files. So now we have organized our files, so they are in good shape now. So let's proceed. Okay, let's ls into the fastq directory again to see the files. So we have them here. What we are going to do next is to assemble the sequence data we have downloaded. Okay, the metagenomic data we have downloaded. We are going to assemble them. But you should take note that we have 6 samples, and therefore writing a megahit command for each of these samples can be cumbersome. So we need to write a bash script, and the bash script will take each of the samples and then assemble them. You should also bear in mind that we are dealing with paired and read, so we need to write a script that will also take into consideration the forward and the reverse. So that's what we are going to do next. So that is what we are going to do next. So let's open a bash script. I'll say nano assemble.sh. You can use any text editor, vi, vim, vi, vim, etc. So just use any of them, but I prefer to use nano, so I'll open it now. I'll add my shebang line. I'll move to the next line. So the next line, I'll specify an output directory. So I'll say outputs there equals, I'll say megahertz results. This directory has not been created. So in the next line, I'll issue a command to create it. So I'll say make the $outputs there. Now let's go to the next line. So in the next line, I'm going to get all the read ones or the forward reads. Okay, so in this tutorial, whenever I make mention of read 1, is the same as forward reads. Read 2 is the same as reverse reads. So I'm going to get all the read ones. So this, there are 6 of them because we have 6 samples. So I'm going to get them. So I'm going to get them, and then once I get them, I'll process those files. So there's a strategy I'm going to use. Let's take, for example, this file name here. This is read 1, okay, the one being displayed. I am going to get this file name. I'm going to split this file name into three components. The sample name or sample ID, and then the read type, which in this case is going to be read 1, and then the file extension, which is going to be .fastq.sanga.gz. So once I get these 3 components, then whenever I want to make reference to read 2, I just need to swap the read type. Okay, in this case, read 1, which is _read_1. I'll swap it with _read_2. Then I'll get the read 2. That is what I'm going to. So that is the strategy we are going to use. So in principle, this strategy can be applied to all your samples. It doesn't matter the number of samples. Once you have a good naming convention, then you can apply this. So it's always important to have a good naming convention, and you can use that too. And that will help you to automate your scripts or your analysis. So let's get back to our terminal. So I'll say void reads equals, I bring a bracket and I'll say fastkill / star underscore read underscore 1 star. So I have all my void reads. Then in the next line, I will issue a for loop. So I'll say for void read in $void reads square bracket at, I end with another curly bracket. So this line here, okay, this command here returns a bash array. So the array will contain all the read ones, the file names. And then here, what we are doing is that we are trying to get each of the files, each of the names. That is what this loop simply does for us, or simply will do for us. So we are going to get each of the file names. So this name here is a placeholder for each of the files. And then we are going to process them. So in the next line, I'll say do. In the next line, this is where the processing takes place. So I'll start by getting the sample ID or the sample name. So if let's say this is the file, then we are going to extract this components. This becomes our sample name or our sample ID. Okay, so that's what we are going to do next. So you say bname equals dollar brackets. I'll say base name, and then I'll say dollar void read. Then I'll add a space and then I'll give some information here. Before I proceed, let me quickly explain this command here. So the base name command here will remove the directory and then will return just the file name. That's what it's going to do for us. So with what I have given, it's going to remove this directory, the fastkill directory, this part here, and then we'll be left with just the names. So let's take a look at the file names here. Okay, we have them here. This command will get all the read ones, the void reads. Okay, so the base name command, which I'll complete very soon, will give us just the file names. So for example, this one here will get just the file name. Okay, with the part of files, it includes the directory as well as the file names. By the base name, we'll remove the directory and we will have just this information here. But what I want is this one here. Okay, so if this is what I want, then I have to also specify whatever I want to remove, and that is this region here. Okay, this particular text here. So what I'll do is to copy this one, and then I'm going to paste it here. And then I'll close the brackets. So what will happen is that bash will remove the directory or the path, and then the file name, this portion will also be removed. Then we are going to get just this one here, and that is what we want. Okay, so that's what we have done now. Now we have this bname or base name. Okay, this becomes our sample names or sample IDs. And so we are now going to move to the next line. So at the moment, we have just the void reads, that is underscore read underscore 1. And so we need to also get the reverse reads, that is these ones, underscore read underscore 2. So all these files, we need to get them. Okay, so this is where it becomes interesting. So what we have done here, what we are going to do is that we are going to swap this name, this one here. Let me just use this one here. So all the read ones that we have, like this one, and then the others, the name that we have, we are going to swap this particular portion. Okay, and then we will add underscore read underscore 2. Okay, so that will give us the reverse reads. That's the trick to all these things that we are doing. Okay, so that's why it's good to have a good naming convention. So because we have a good naming convention, because there is a text that can be used to distinguish between the forward and the reverse, all that we have to do is to swap those texts and we will get our reverse. So that we don't need to write another command to get all the reverse reads. So that's what we are going to do next. So I'll say reverse read equals, and I'll say dollar, I'll bring my brackets and I'll say echo dollar forward read, and then I'll bring my pipe and I'll say set. So the set command is what will be used to swap. So the set, I'll give my quotes, I'll say s/, and then that's what I swap this with 2. So I can say read underscore 1. I'll just copy this one here because that's what we need. And I'll add another slash and I'll say read underscore 2. I'll add another slash and I'll say gen, and then I'll add my quotes and then I'll close this brackets. So this command here will give us the reverse reads. You will notice that I indicated read underscore 1. Okay. The reason why I did this is that even though all the reads, we can differentiate them with 1 and 2. If let's say you have 1 in your sample names or in one of the sample IDs or whatever, then when we issue the set command here and we indicate just 1 and 2, that means all the ones will be replaced, including this one, for example. So that is why I added this, so that this becomes a unique name or a unique text. Okay, so once we have this unique text, then set will just take a look at that and swap only those patterns. That's the trick behind whatever we are doing. Okay, so that's what we have. Okay, so that is what we've basically done here. So once we have done this, then it becomes easy to issue another command. In this case, our megahertz command, and then assemble all our samples. So that's what we are going to do next. So the next thing we are going to do is to issue our megahertz command. So we will come to the next line and then we will issue the command. So with the megahertz command, we are also going to have some options. So we will use the options that were indicated in the original Galaxy tutorial. So let's take a look at those options. Okay, so we are on the page now. So in this tutorial, they also indicated the KMA specification method. So they indicated the minimum KMA size 21, maximum KMA size 91, and an increment of KMA size of each iteration 12. So we are going to also use the same option. So let's go back to the terminal and then add those information. So when we are here, we will say megahertz. Let me just move down a bit. So I'll say megahertz, I'll say -1, that is $forward read. Let's make sure we have spelled everything correctly. And then we have -2 for reverse, so that will be $reverse read. And then I'll have -k -min. That's the minimum KMA size, and that'll be 21. We have -k -max That's maximum, that will be 91. And then the step, that will be dash dash k dash step. And that will be what? 12. And then we are also going to indicate threads. So I'll say dash t, and then I'll indicate the number of threads. So I'll use 8 here. And then I'll also say dash o, that'll be the output directory. So that will be $output dar /$b name, like this. Let's put quotes here just to be safe. Then this one's to let's add our double quotes. So that's what we have. Now let me talk about the dash t. Dash t is for number of threads. So here you can increase it depending on the computing power that you have available to you. The genome assembly process is computationally expensive, so it's always advisable to use a high-end PC, or better still use a computer cluster so that you can use more cores. So if you're using an HPC cluster, then you can increase this number, this 8 here, to 10, 20, 30, or whatever you have available, and that will make the process faster. So make sure you do that. Now we are done with this, so we'll move to the next line. We are going to say done. Okay, and then we can just save the changes and exit. So let's do that now. Okay, now we have saved the changes. So we can do an ls just to make sure our script is there, and that is what we have here. What we are going to do next is to add execution rights. So I'll say chmod +x, and then I'll say assemble.sh. So now I can execute the script. I can do an ls again just to see what has been done. So it depends on the Linux platform you are using, the color of the scripts may change. Okay, but once you have issued this command, everything is fine. Okay, so now we are going to execute the script now. So with execution, you can say bash, and then you can specify the file like this, or you can also do this // and then call the file like this. I'll use this approach. So let's execute this command now. Okay, the genome assembly process has started. So let's wait for Megahit to complete its work. Okay, Megahit has completed its work. So let's take a look at the output files. Okay, we are now going to take a look at the output files. So let's do an ls. We are going to see this directory. So this has the output file. So let's ls into it. So I'll say ls megahits_results, and I'm going to see all these directories. So each of these directories represents a sample. Okay, so in each of these directories, you will find the output files for each of the samples. So let's use this one for example. So I can say ls megahits_results / and then I'll indicate the sample name. And then I'm going to find my files here. Okay, so this file here contains contigs, that's the sequences. So you can process these files further, you can analyze them further. So after genome assembly, one of the things you can do is to evaluate the assemblies. You can use tools like Quast to do it. And after evaluating, you can also visualize the assemblies using tools like Bandage. But these are things that I'm going to cover in another tutorial. So once I do that, I'm going to leave the link in the description box for you to check. So for now, practice what you have learned and try to also use the skills you have obtained to write bash scripts to analyze or process other files. So I'll see you in the next session.